I also be able to inject methods, right? So I injected a new method. I created a method called hide file. You can see it here. This is the code of hide file. Okay? So now I've actually extended the runtime. I'm providing a method in which I can use. So it allows me, you know, like any good software developer, instead of having one big chunk of code, I'm compartmentalizing a little bit. So it allows me to do parameter passing and basically to write better code. So now all I have to do is provide it with the parameter that I want to call. And this is the implementation of the method itself. So actually, when I call this file, right, when I deploy it, and if we look at the virtual machine itself, let's go to the sorry. Yep. This is the shell for the Google Android. So this is the basic command line, and now what I'm going to do, I'm going to go to system. Well, system contains all of the important information about the runtime, and I'm going to framework. Framework is where the runtime of the Google Android runtime contains the Dalvik classes. So this is where all the interesting thing happens. So back here you can see the two files, the core and the core patched. And what I'm going to do, I'm going to copy this patched file over the original one. So now overriding the file itself, and I'm going to go back to the system file. And And what I'm going to do now, I'm going to create a couple of files. So I'm going to create, let's say, file that's inside SD card and called 1.txt, another file called 2.txt, and the third one called secret file.txt. Okay, so got back to the runtime itself. Go to my file manager, and if I'm looking at the SD card, I see only the two files that the runtime is supposed to see. Of course, if I will create another file, 3.txt and 4.txt, well, I will see only those that I want the runtime to see. So we actually created this alternate reality. So if this is the real world, right? This is what happens inside the matrix. So now it allows me to do interesting things. I can hide processes. Okay, I can hide processes. I can hide everything that I want. I can influence the execution itself. Yeah.
So the basic assumption is that those jar files are not signed or anything. So like if those are modified.
This is a good question. Well, let's say that they were signed, right? They're not signed. But let's say that they were signed. Well, if I'm an attacker and the machine has already been compromised, nothing can stop me. So even if it was compromised, think about it. Even if it was compromised, if it was signed, there must be some kind of a private key lying around somewhere, and an associated public key to perform the signing and the verification. Well, I can just replace them and re-sign again. So actually, if you have a full control of the machine, you cannot do anything about it. This is exactly the definition of rootkit, because you cannot fight something which is on the same level as you are.
So on timing of this, when you replaced core.jar on Dalvik, you didn't have to restart the JVM.
No.
You didn't have to restart the
No.
runtime. So
No.
the class loader is picking up the changes
Yeah.
as you make them?
Yeah. Well, what I do have to do sometimes, well, in this situation I didn't have to do it, is to clean precompiled images. So, for example, if I want to go back to the real world, right? So, for example, I'm going to copy the original, I think it's over here, core, oh, it's in backup. And over to here, right? And basically I want to remove all of the precompiled images is an images that was already compiled to the specific machine, so that the JIT, remember the JIT, doesn't have to go and compile again and again. So it saves the machine-specific instructions. So I have to remove it from. This is in data, Dalvik. So this is the Dalvik cache, and remove everything. So if I want to go back, for example. This is if I want to do a real cleanup, right? So if I go and do it again, and go to my SD card, now I can see the file, right? So this is the actual change this is what happens if it wasn't modified. Okay, so the basic steps that I did is written over here. You can have it for reference. Of course, the slides will be here. It's online. You can download them and do everything you want with that. So I showed you that we can do method injection. We can actually add new methods and new classes. Basically, we can extend the runtime so that it will allow us to do something that wasn't intended at the first place. And I implemented a couple of examples. One of them is hide file that you saw, hide processes, send to URL, we send information to external URL, and basically other interesting things. Another interesting thing about injection for virtual machine runtimes is that they're object-oriented based. Object-oriented means that when I'm injecting to a specific class, basically I'm injecting to all of the classes that inherits from it. In object-oriented models, all of the methods, we do not have a shallow execution model, so that every method, every class inherits from another class. And all of the classes in this hierarchy, all of the classes inject from object. So for example, if I'm injecting code to object, well, I'm actually injecting to all of the classes, right? This is kind of interesting because it allows me to decide where I want to inject. For example, if I want to inject just to one branch, just to this area, I will inject to this class and everything inherits it automatically. Another example is with authentication backdoors. Think about it. What happens if someone manipulates the authentication method for the runtime so that application calls the authenticate method? It will lie to the applications, right? So that, for example, if you want to inject something that says, if the password equals some kind of magic value, let the user in. So this is a kind of master key that lets you enter inside each and every one of the users. You can just inject it to the authenticate method. This is an example of a .NET rootkit on the authenticate method. Another interesting thing is what happens. It's something that I call the false sense of security. Do you see this picture on the right? This is a real picture. Someone actually bought a lock. And this is how he locked his bicycle. False sense of security is one of the bad things that can happen to security because you're thinking that you're okay, but you're not. You're thinking you did the right thing, but you're not. So basically, someone can hack your system. And one of the interesting things is what happens with false sense of security regarding to crypto attacks. Well, think about it. What happens if someone tampers with the crypto libraries and changes the method that is responsible for generating random keys for encryption? So if this is the real code, let's say that we replaced it, so now we have this code. So that now the random number generator returns a fixated key so that the application developer thinks that he's encrypted the data. Well, he encrypted the data, right? Only that the data, the attacker knows the key, he controls the key. And the output looks encrypted. Well, it is encrypted. Another example is what happens if someone sends the key to some remote location. And another example, this is called algorithm downgrading. This is what happens when you're calling some kind of a crypto algorithm, which is considered good, but the algorithm is being downgraded to a bad algorithm. For example, if we take AES, the advanced encryption standard, and replace it with DES, so that the application calls AES, at the bottom level, the actual encryption is being done with AES, so that the other guy will be able to crack it very easily. Another example is when we're changing the modes. going from CBC to ECB, right? Going to CBC